Hello everyone and welcome back. My name is excuse me, Mr. Cobalt, and in this video I'm going to be going over a couple of examples of how you can figure out what the KP is if you're given the KC, or if you're given the KC, what the KP is. And again, what I mean by KP is the equilibrium constant in terms of pressure, and the Kc is the equilibrium constant of reaction in terms of concentration. And so if you know the relationship between the equilibrium constant in terms of pressure versus that in terms of concentration, then this is a really easy way to solve the problem. So the equation that you have to know is this equation right here. So the equation here is the equilibrium constant in terms of pressure is going to be equal to the constant in terms of concentration multiplied by RT, both raised to the change or in the number of moles. And again, the delta N here is the change in moles between your products and the reactants. And so that's what that means. And so we'll go over this problem here first. So we're given this equation that 2NO gas plus oxygen gas is going to give you 2NO2 gas. And they give you the Kp value, and they want to know what the Kc, the equilibrium constant with respect to concentration, is. So if we use this equation, then we're given Kp, we need to find Kc, and we know what the R value is, the ideal gas law constant value, and we know that temperature is as well. And so what we need to find is temperature. Temperature has to be in Kelvin, and we're told, actually I didn't write it down, let me double check, it is 25 degrees Celsius, so this is 25 degrees Celsius, same as here, so 25 degrees Celsius here as well. So we need to change this to Kelvin. So remember, to change your degrees Celsius to Kelvin, you add 273.15, and that's going to give you 298.15 Kelvin. Since we're adding the sig figs are determined by the number of decimal places. So since this has 0 decimal places, so then we're only limited to the ones place, since that's our least precise measure, is the ones place here versus the hundredths place. So just to keep track of our sig figs. All right, so we have our temperature. What about the change in number of moles? So delta N is going to be the change in moles between your products and reactants. So we have 2 moles. The moles are going to be determined by the coefficients. So I have 2 moles of product formed, 2 moles of NO2, and from that I get this from 1 mole of oxygen and 2 moles of NO. So that's 3 moles total on this side here. And so this is going to be the number of moles of product minus the moles of reactant. So we have 2 moles of our product minus the total moles of reactant, which is 3, and that gives us a -1. So the power is going to be -1, so this is going to be -1. So if we solve this for Kc, which is what we're looking for, so Kc is going to be equal to Kp divided by RT to delta N. So if we put in our values, so the Kp is 2.2 times 10 to the 12 divided by RT. R is going to be, here I'll put this as a square bracket, R is 0.08206. Okay, and this is just to write down the this is the units. atmosphere liter over Kelvin mole, right? And then we're going to multiply that by the temperature, which is 298.15 square bracket, and all of this is raised to the -1 power. So if we plug this into our calculator, we should be able to calculate it out. And that brings us to 5.4. So Kc is going to be equal to 5.4 times 10 to the 13. So this is the Kc from the Kp. Okay, what about problem number 2? Problem number 2, I have hydrogen gas plus iodine gas is going to give me 2Hi gas. So here they're giving me the Kc, and now I want to find the Kp. So same equation. So Kp is going to be equal to Kc multiplied by RT delta N. Okay, so T, again, it's 25 degrees. We're at 25 degrees Celsius plus 273 is going to give us 298 Kelvin. Okay, our delta N is products, moles of the products minus moles of the reactants. So here we have 2 moles. So our delta N is going to be equal to 2 moles of our products minus 2 moles of our reactants is equal to 0. So then this is going to be Kp is equal to Kc, because this is 0, right? So RT to the 0 power, anything raised to the 0 power is 1. So this is all 1. So Kp, so Kp is equal to Kc. So it's the exact same number, 6.2 times 10 to the 2. So that is the answer. So this is a useful equation. I hope this was helpful. If you like this video, like, share, subscribe, hit the notification bell, and I'll see you guys next time. Thanks for joining me.